coffee? Ay. What?
Kaya, bumili ka ng suka doon?
Si Chloe na lang pagbilan mo.
Ay, sorry po. Pasensya. Ayos lang po kayo.
Wait lang.
Ayun po.
Parang babagsak ka sa baskal mo ah.
Paano niyo po nalaman na may test kami bukas sa Basket?
Kasi nakikita ko yung kapalaran mo. Parang hindi ka bumagsak sa iyong pagsusulit sa baskal.
Ano po yun?
Meron isang riddle. Kailangan mong sagutin. Yung riddle na yun ay I travel by night and fade by day.
I travel by night, fade by day.
Tandaan mo yun.
Opo. Maraming salamat po. I travel by night, fade by day. Fade by day, travel by night. Which siya tayo na? Which? Baka hindi. Bibingka. Ha? Bibingka. Travel by night, fade by day. Dream. Wow. Dream.
Hello, ako si Dream Sub 1 at ito si Dream Sub 2. Dahil nasagot mo ang bugtong, bibigyan ka namin ng isang kahilingan para
Nice.
matupad ito. Pero bago yon, kailangan mo muna pirmahan ito.
Okay. Seems legit.
So, anong wish mo?
Pwede akong paturo ng basta.
Oo, ayos lang.
Okay, fine. That's nice. Okay lang yan kung umpisa na.
Ngayon na. So, ang una namin tuturo sa'yo ay ang higher order derivatives.
Okay.
Kaya makinig ka na mabuti.
In the previous episode, we only dealt with the first derivative of functions which can be obtained by applying various differentiation rules. Now, we extend this concept by finding the derivative of a derivative. This is called the second derivative. The second derivative and subsequent derivatives are called higher order derivatives. Let's try to get the first, second, third, and fourth derivative of the function f of x is equals to x raised to 5 minus 2x cubed plus 4x squared minus 5x minus 12. By applying the basic differentiation rules, we can get the first derivative of this function, which is f prime of x is equals to 5x raised to 4 minus 6x squared plus 8x minus 5. In order to get the second derivative, derive the first derivative of the function. We will then get 20x cubed minus 12x plus 8. And if you're trying to get the subsequent derivatives, just repeat the same steps in getting the second derivative. We will now then have the third derivative, which is 60x squared minus 12, and the fourth derivative, which is 120x.
Madali lang pala, no? Okay. Ito naman yung chain rule. Paano yan?
Ganito lang yan.
In this lesson, we shall introduce a more general form of differentiation. This is called the chain rule. But when can we use the chain rule? We can apply this rule. First, in a function raised to a number. Example of these functions are the following. We can also apply the chain rule in a function within a function. Example of this is y is equals to sign multiplied to the quantity of 3x squared plus 3. Find the derivative of the function x squared plus 2x raised to 3. Using the power rule, we can get the derivative of the function x squared plus 2x raised to 3. The exponent of the function, which is 3, will be multiplied to the coefficient of the given function, which is 1. We will have 3 multiplied to the quantity of x squared plus 2x. In order to get the exponent of the new function, we'll simply subtract 1 from the original exponent, which is 3. We now have 3 multiplied to the quantity of x squared plus 2x raised to 2. But we are not yet done, because we still need to derive the function inside the parentheses. Using the basic differentiation rule, we will get 2x plus 2. This will be multiplied to 3 times the quantity of x squared plus 2x raised to 2. Thus, we have our final answer, which is f prime of x is equals to 3 times x squared plus 2x squared multiplied to 2x plus 2.
Mas madali pala yung chain rule eh. O yung implicit something.
Ito ba yun? Yung implicit differentiation.
Ay, oo, yun.
Madali lang to.
In this lesson, we're going to find the derivative of equation using the process of implicit differentiation. Let's have an example. Let's try to get the derivative of y with respect to x of the equation x squared minus y squared is equals to 16. First, we need to differentiate both sides with respect to x. So we're going to have d over dx multiplied to the whole equation. Now, we're going to apply differentiation rule. We're going to have 2x multiplied to the derivative of x with respect to x minus 2y multiplied to the derivative of y with respect to x is equals to 0. We can cancel the derivative of x with respect to x in the equation. So now, we have 2x minus 2y multiplied to the derivative of y with respect to x is equals to 0. All we need to do is group the terms that contain the derivative of y with respect to x on the left side and the remaining expressions on the right side. Now, let us solve for the derivative of y with respect to x. Divide the whole equation to 2y. We're going to get 2y multiplied to the derivative of y with respect to x over 2y is equals to 2x over 2y. Now, we can cancel 2. Therefore, our final answer is the derivative of y with respect to x is equals to x over y. Now, let us proceed to related rates. This concept of related rates is another important application of differential calculus involving variables that are related with respect to the time. Let's have an example. The problem is, air is being pumped into a spherical balloon at the rate of 4 centimeters cubed per minute. Find the rate at which the radius of the balloon is increasing when the radius is 10. Let V and R denote the volume and radius of the balloon respectively. Step 1. Illustrate and label the figure. Step 2. Identify the known and unknown quantities. The volume of the balloon is increasing at rate of 4 centimeters cubed per minute, and we want to find how fast the radius is increasing when R is equals to 10 centimeters. Step 3. Formulate the model. We can use the formula of the volume of a sphere as a function of R, which is V, is equals to 4 pi over 3 multiplied to 3 cubed. Step 4. Implicitly differentiate the model with respect to t. We're going to have the derivative of v with respect to time is equals to 4 pi r squared multiplied to the derivative of r with respect to time. Step 5. Substitute the given quantities into the resulting equation in step 4 to find the desired rates. Using the given quantities, we have 4 is equals to 4 pi multiplied to 10 squared times the derivative of r with respect to time. Solve for the desired rate. We're going to have the derivative of r with respect to time is equals to 4 over 4 pi multiplied to 10 squared. Thus, this means that at the time when the radius is equals to 10 centimeters, the radius is increasing at the rate of 0.00318 centimeters per minute.
Nakatulog ako. Uy, late na. Kailangan ko mag-aral.
Sige. Ba't di ko mag-aral?
Carlos Martinez.
Ay, nice. Na-perfect ko to.